Hello students, let us discuss about thermal energy. In the previous class we have seen that intermolecular forces and types, that is London forces and dipole forces, dipole induced dipole forces. So today let us discuss about thermal energy. Before going to this, means the thermal energy is interlinked to intermolecular forces. So what is intermolecular forces? So intermolecular forces is nothing but what here? So intermolecular forces is nothing but here. So the force which is attracting the molecules, means attracting the neighboring molecules, that when we call it as intermolecular forces. So that is only the meaning inter means or two different molecules we are taking, means the side by side molecules, neighboring molecules if you have been taken. So it is what happening here, we are going to, the molecules is going to attack, that when we call it as intermolecular forces. So then what is thermal energy here? So the thermal energy is nothing but here the measure of average kinetic energy of the molecules of the substance, we call it as thermal energy. So means what here, the measure of average kinetic energy means what here, if you take a solid state here, so individual molecules we are taking, so means for each and individual molecule we are taking a energy. Okay, if you take only one molecule, we should have to see for this molecule kinetic energy. So means what we are measuring here, means we are taking the average of the each molecule on the substance, we call it as what here, thermal energy. So this is nothing but thermal energy. So coming to here, generally this, when you take whenever, means what here, the atoms or molecules, so the energy of the molecules, whatever atoms or molecules we are taking, it is moving. Okay, so then what we can say, this is directly proportional to temperature of the substance, we can say. So what we can say, so this thermal energy is directly proportional to temperature of the substance. Okay, so means what, by this we can say, it is the movement of the particles, the whenever the particles is moving, automatically we can say it is a thermal motion. Okay, so now let us see about here intermolecular forces. And so what we can say here, it is due to why this thermal energy is happening, this is due to why, means it is due to the movement of atoms or molecules of the substance. When you take a substance, in substance we are having atoms or molecule. Okay, for each substance we have to calculate the energy. So why this is, when the atoms or molecules are moving in the substance, automatically we can calculate for here thermal energy. So now let us see about here intermolecular forces vs thermal energy. So now let us see what is the relation between thermal energy and intermolecular forces. So coming to here, already we have learned that intermolecular forces, whenever you take molecules together, means they will be having some of the, okay, they will attract each other, okay, neighboring atoms. But here what happens, the thermal energy of the molecules will keep the molecules apart. So when the force, whenever the molecules are attracting, then the thermal energy of the molecules, what happens, the energy of the molecules will be far away. Why? Because they are going to reduce the thermal energy. Okay, if you are taking three states of matter, okay, which is give balance between intermolecular forces and thermal energy of the molecule, that is solid, liquid, gas. So what I have told you here, so here the intermolecular forces attract each other. Intermolecular forces, what happens, it will attract each other, means what here, the molecules will be very closer here. So when you take the molecules together, that is the meaning, together tends to keep the molecule together means what? It will be very close. But what happens? The thermal energy. But the thermal energy, what shows here? The thermal energy tend to keep them apart. So means what here? Here the molecular energy will bring the closer, and coming to here thermal energy, what happens? It reduces the molecule. Okay. So what happening here when molecular interactions are very weak? So if suppose the interaction is very weak and the molecules do not move to make liquid or solid, okay, but what happens? Sun thermal energy is reduced. So if it is a weak, I'm saying what here, clearly observe here what I'm saying here, the molecular interactions are very weak. Whenever the molecular interactions are very weak between the molecules, if you take these molecules, if there is a weak interaction between, so what happens? The molecules do not go to an solid or liquid state. Why? Because so unless the thermal energy is reduced, so it will not change into the solid and liquid. Okay, have you clear? I think if suppose gases also in the same way do not liquefy on compression only. Okay, so means what here? If the molecular forces are weak, if suppose molecular forces are strong, means automatically what happens? The thermal energy of molecules is automatically reduced by lowering the temperatures, then easily the gases can be changed into liquid. So means what here? Predominance of thermal energy and molecular interaction. So here we are taking three states. Generally we are having two conditions. What is that condition means? If thermal energy predominates is nothing but strength or influence. Thermal energy is influencing intermolecular forces. The substance changes. So means what here? What is the meaning of this? So here the thermal energy is influencing the intermolecular forces. So then automatically what happens? The solid is changed to liquid. Liquid is changed to gas. If suppose intermolecular force, if intermolecular forces predominance, if intermolecular force is influencing the thermal energy, then automatically what happens? The substance changes. So means what here? The gas is changed to liquid, the liquid is changed to solid. So this is the thing is going to happen. So this is due to what happens? This is due to intermolecular force, this is due to thermal energy. When thermal energy influence the intermolecular force, means what here? Here thermal energy is decreasing the intermolecular force. Coming to here, what happens? This intermolecular force decreasing the thermal energy. So this is the thing we are going to happen. So this is nothing but what here? Intermolecular forces vs thermal interactions. So let us see about the gaseous state. Let us speak about what is next one here. We are going to speak about the gaseous state. So the gaseous state. So this is the simplest state of matter. Matter consists of solid, liquid, gas. So gas is nothing but what? Gaseous state. So here the molecules is in random position, which is not in order. It will be not having any definite, not having no definite shape and no definite volume. That one we call it as gaseous state. Yes or no? And also here density is also very low. Okay, that's why I said here the molecules what you can take, they can move freely. They will be not having any restriction to stop them. So means what? They are easily can compress. So when you take here, this is the simplest, that's why I have told you. So throughout our life, when you have been take, we remain immersed in the ocean of air. Yes or no? So means what? We are not mixing with the ocean and air. So that one which is a mixture of gases. Mixture of gases is nothing but what here? If you mix two gases, that one we call it as mixture of gases. But coming to here, throughout our life, we remain immersed. Immersed is nothing but in the ocean of air, which is a mixture of gases. So we spend our life in the lowermost layer of the atmosphere. That one we call it as what here? Troposphere. Yes or no? So what we are spending? We spend our life lowest layer of the atmosphere. Atmosphere consists of stratosphere, troposphere, hydrosphere, lithosphere. These all spheres we are having. But coming to here, what happens? We are spending our life lower the atmosphere, lower layer of the atmosphere. That one we call it as troposphere, which is the surface of the earth. Okay, by gravitational force we can say. The troposphere consists of what here? The surface of the earth by gravitational force. Then what happens? The thin layer of the atmosphere is visual to our, is very important to our life. So that's why what we can say, it shields us from harmful radiations and contains substances like dioxin, nitrogen, carbon dioxide, water. So it is protecting our lives, the atmosphere, very thin layer. So and we are protecting from harmful radiations like UV, visible, X-rays. So from these rays we are protecting from the troposphere, atmosphere. So this substance contains what here? The substance like dioxin, means what here? O2, N2, CO2 and water vapor. So this is nothing but gaseous state. Okay, so let us focus our attention on the behavior of substances. Okay, so which exist in gaseous state under normal conditions of temperature and pressure. So now let us see periodic table. There are only 11 elements, that is in group 1, 15, 16, 17. So we are having 11 elements. So that is hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon. So these are the 11 elements which are exist as a gas in the periodic table, means at normal temperature. Okay, so the gaseous state, it is having physical properties. So means what it is having? The gases should be, gases are highly compressible, means which can easily compress. Okay, so it will give pressure equally in all direction. Gases exert pressure equally in all directions. Okay, so these have lower density than the solids. Low density than solids and liquids. Okay, and coming to here, the volume and shape of the gases are not fixed here. No definite shape and volume we can say. Okay, so coming to here, gases mix evenly and completely in all proportion without any mechanical add. Without adding only, the gases can mix completely, we can say. And also here, simplicity of gases is due to what we can say, due to the force of attraction between their molecules are negligible. This is because of some laws which was discovered by their experimental studies. Okay, so what we can say here, the simplicity of gases, simplicity of gases is due to what here? Is due to the force of attraction. Force of attraction between their molecules are negligible. If molecules is not having any force of attraction, that one we call it as the gas molecule is a The gas molecule is what? Simple. Okay, why? Because there are some laws which were discovered by their experimental studies, we can say. So these laws are relationship between properties of gases only. Because of these properties, we can say, so these properties like pressure, volume, temperature, mass is very important, because the relation between these variables, we call it a state of the matter or state of the gas. Okay, so there is a dependence of this variable laws, the gas laws we are going to have. In the next class we can discuss about the gas laws. Thank you.